A proportion is formed when two ratios are set equal to one another, or when two rates are set equal to one another. A proportion looks like this. It's just one fraction set equal to another fraction. And there are several tasks that we're going to perform with proportions. The first one is to decide whether or not the proportion statement is valid, whether or not that is, this fraction is equal to that fraction, you see, basically. And to decide that, there are a few ways to do that, but one way is by using cross multiplication. Now, by cross multiplication, I mean to multiply the numbers that lie along diagonals. 6 times 4, that's a cross multiplication. 8 times 3 is a cross multiplication. So here's what we're doing. 6 times 4 is 24. And then along the other diagonal, 8 times 3 is also 24. So because these are equal to one another, we know that the proportion is valid. Are these proportions true? Now, to decide, once again, we're just going through a little cross multiplication business. So to decide, and it doesn't make any difference which product we consider first. We can go this way first or this way first. Doesn't make any difference. But if we go along this diagonal, 5 times 16, let's see, 5 times 6 is 30, carry 3, 5 times 1 is 5, and 3 is 8, so this is 80. All right, now, that's along this diagonal. Along the other diagonal, we have 8 times 10. 8 times 10 is also 80. So this is a true proportion. Now when we're trying to decide on whether or not a proportion is true. The equality is really questionable. You see, we're questioning whether or not it's true. We decide that it is true because of this cross multiplication equality idea, and then we can say yes, the proportion is true. All right, for this one, what about 3/5 and 10/15? Well, again, we cross multiply. 3 times 15 along this diagonal. 3 times 15 is 45. And then going along this diagonal, 5 times 10. Oh, that would be 50. These are not equal to one another, so no, this proportion is not true. It is most often the case that when we're dealing with proportions, we are trying to solve for something that's unknown in the two fractions. And it'll be one of the numerators or one of the denominators that'll be unknown. Here, for example, we're trying to solve for this numerator. So n is standing for some unknown value, and we want the value of n so that this proportion will be true. Now, if the proportion is to be true, we know that the product along the two diagonals is going to have to be equal to one another, and that becomes the technique for solving the proportion for n. So here's what we do. We think about multiplying along this diagonal, the letter n times 20. Well, we don't know the value of n, but we can certainly write the product of the letter times the number, and we write it like this. Just 20n means 20 times n. You see, and then along the other diagonal, it's 5 times 12. So it's this kind of thing. Now remember, we can illustrate the multiplication in several ways. We can use a little cross here, which I've done, or a dot or parenthesis would indicate multiplication as well. All right, now, on the right side, we have a little work to do. We can find that product, and 5 times 12 is 60. Now, we still haven't found the value of n that'll make this true. And the way we do that with this kind of equation is like this. We're going to actually make the equation tell us the value of the letter that makes this statement of equality true. And to do that, to make it tell us, we're going to isolate the letter on one side of the equal sign or the other. Now, we're going to isolate this letter n on one side or the other, and therefore make the equation say n equals some number by doing this. We're going to eliminate the 20, which is next to the n. Now, how do we do that? Well, this is 20 times n. And to undo this multiplication, we'll do the inverse operation. We'll divide. And it turns out that here's what we'll do. We'll take 20n and divide by 20. Now when I divide by 20, these 20s will cancel with one another, and I'll be left with an isolated n. And that's what I want to have happen. But if I divide over here by 20, I need to divide over here by 20, because I have equality. I have a statement of equality. The value over here is equal to the value over there. So if I perform some operation on one side, I need to perform exactly the same operation on the other side in order to maintain that balance. So dividing by 20, these cancel. I'm left with n as expected. When I take 60 and divide by 20, I get 3. So I'm claiming here that n is equal to 3 will make this original statement, this original proportion, true. That means that I'm thinking that if I replace n with 3, that 3 over 5 will be equal to 12 over 20. So I can check that using the idea of checking to see if a proportion is true from our previous problems like this. I can say, okay, I want to check. I want to see if replacing n with 3 will make this true. So I write the proportion with the n replaced with 3, and I go through this cross multiplication. 3 times 20 is 60. 5 times 12 is also 60. A true statement, a true proportion. So when n is replaced with 3, we have a true proportion. All right, we have solved then the proportion for a certain unknown letter. Now the unknown letter in a proportion could appear in any of the 4 positions that are available for numbers in the two fractions. So the unknown letter could be in any numerator or any denominator, and we ought to be able to solve for it. And the method of solution is to cross multiply and then to eliminate the number next to the letter by division. Well, let's go through the process again. Now I can decide to cross multiply in either direction first. Now, if you'd like to have the letter appear on the left-hand side of the equation, then go along, multiply along the diagonal, which involves that letter first. And it'll always appear there. But it really doesn't make any difference. It can appear on either side. Suppose I decide in this problem to multiply along this diagonal first. So I would have 4 times 16. And then I multiply along this diagonal 9 times n, which is 9n. Now 4 times 16, let's see, 4 times 6 is 24, carry 2, 4 times 1 is 4, and 2 is 6. So 64 then is equal to 9n. Now I'd like to isolate the n, and to isolate that n, I'm going to divide by this number that's next to it. You see, because then I'll get a cancellation, which is what I'm interested in for that isolation purpose. So I'll divide on both sides. I'm going to show that I'm going to take each side and divide by 9. And the 9's will cancel here, leaving n as expected. And my answer is going to be over here, and it's going to be the result of this division of business that I have. 64 divided by 9, gee, I can't see through that. I might use the calculator you see at this point and put down some decimal version of this quotient, or I could go to the side and do it like this. 64 divided by 9, well, that's 9 into 64. 9 goes into 64 7 times. 7 times 9 is 63. When I subtract, I get 1. Now, if I want to write a mixed number, I would take this remainder and put over the divisor. I'd have 7 and 1/9 then as the value of n. So let's slide over here, 7 and 1/9. Sometimes the nature of the problem is going to dictate whether you use a mixed number like this or whether you change it into a decimal that is rounded to a certain position or something like that. But if there are no instructions in that regard, then it really doesn't make any difference which method we choose. And this is a very exact value for the value of n. Once again, we could go through the process of checking this by replacing n with the value we found and verify that we have a true proportion. In this problem, we want to use a proportion to find a unit rate. We found unit rate using a different method before. The method was to simply reduce a fraction, basically. But here we want to use a proportion, and it's important with proportions to have the same sense on both sides of the equation. Now, when I talk about the same sense, I mean the same unit structure in the fraction on the left side and the right side of the equation. Here's what I'm talking about. The problem says 270 miles are traveled on 15 gallons of gas. Use a proportion to find a unit rate. Now, the unit rate we want to find is the miles per gallon, you see, the unit rate for mileage in this situation. Now, if we're trying to find miles per gallon, that sort of gives us a hint as to how we want the fractions to be structured on both sides of the equation. So you would set up miles over gallons on both sides. And I'm suggesting here rather strongly that we set up the units involved on both sides before we even introduce any of the numbers involved. So we have this structure, and it's important that miles be on top. If miles are on top over here, miles have to be on top on the other side. That's the important issue. The problem could be worked, by the way, if we put gallons on top over here and gallons on top over here. But it kind of follows our unit rate structure for miles per gallon if we have the miles on top and the gallons on the bottom. A little easier. Okay. Now, let's fill in with some numbers. It says 270 miles are traveled on 15 gallons of gas. So we have 270 miles on 15 gallons of gas. And we want to know what this corresponds to as a unit rate. Well, the number of miles in this unit rate is unknown to us, so we'll just let a letter stand in for the number of miles. And for unit rate, the idea is it's the number of miles on 1 gallon of gas. So in miles on 1 gallon. And now we have the structure for a proportion, and we go through and solve. Now the solving means that we ignore the units for just a moment, and we're concentrating on the numbers and the letter. So let's first cross multiply. Let's go this way first. N times 15 is 15N. And 270 times 1 is 270. Now we'd like to isolate the n, and we know that we do that by dividing by 15 on both sides. So we'll divide on the left by 15, and we'll show the division of 15 on the right as well. These go out. So we find that n is 270 divided by 15 turns out to be 18. So 18. Now what is 18? Well, if we forget, we can always look up into the structure of our equation here to see. N stood for the number of miles. So this is 18 miles, but it was 18 miles per gallon. You see, 18 miles in 1 gallon. So we write this then as 18 miles per gallon for the unit rate. This problem involves a proportion but not a unit rate. It involves a medication, and let's say that on the bottle of the medication or in the literature for the medication we know that 2 ounces of the medication is required for every 50 pounds of a patient's body weight. And we'd like to calculate the number of ounces required for a person who weighs 175 pounds. So we're going to set up a proportion to accomplish this, and we set it up in much the same way that we did before. Just make sure that the units are consistent on both sides of the equation. So we're talking about ounces and pounds here, so we set it up like this. If we set it up as ounces over pounds on one side, we have to have ounces over pounds on the other side. Now, what do we know and what do we want to find out? Well, we know that 2 ounces corresponds with 50 pounds. 2 ounces corresponds with 50 pounds. And we'd like to know how many ounces, some unknown number of ounces, let's call it X this time, is required for a person who weighs 175 pounds. So away we go. Now we're cross-multiplying. Either direction is fine. 2 times 175. Let's go in that direction first. 2 times 175 on one side. X times 50, or 50 times X, on the other side. Now we'll divide on, we need to multiply on the left. I'm kind of running out of room at the bottom of the board, so let's come up over here. On the left side, 2 times 175, well, let's see, 2 times 5 is 10. 2 times 7 is 14, and 1, 15. I'm carrying 1. 2 times 1 is 2, and 1 is 3. So that's 350 on the left side. On the right, we have 50x. Now we'd like to solve for x, or isolate x on one side of the equation, so we'll divide on both sides by 50. And we show that in a step like this. Now the 50s will cancel on the right as expected, leaving X isolated. Then 350 divided by 50 turns out to be 7. So this is 7 ounces then of medication necessary for the person weighing 175 pounds.